Hey there, welcome back to the stream. Today we are going to be continuing working on the YoshiStat, which is a smart thermostat. This is, I don't know, I think we are on about episode 4. I'll put a link up in the corner over here to the previous one. Also down in the description there will be more, that kind of thing. Let's first do a quick recap of what we have going on. So we've got basically an application for a smart thermostat, and we've got this broken out into a couple of different projects. We've got a desktop project and we've got a YoshiPi project. Let me show you what that hardware looks like here. So here is the hardware that we're going to be targeting. Because it's challenging and a little slow to target a device, we're also going to be targeting a desktop that allows us to simulate things. So if we come back over and take a look at the code, you can see I have a desktop project and I have a project for the YoshiPi. We also have a core project that has logic that is common to the both. Right now, if we take a look and we just run this desktop app, let's take a look at what it currently does and, what it is that we need to implement next. So I'm going to run this. This has changed a little bit since my last stream. We have had a little bit of design work done to it. I don't think a whole lot, but it is a little bit different. So you'll see we've got this, and I was a little bit slow. Came up, there was a splash screen, and now we have this. So we've got a temperature, time, and humidity here. This is all that it has currently. What I'm going to do is today we're going to work on the control algorithm for this. Imagine on a thermostat that you want to set the temperature that you want your space to be to, let's say, 65 degrees. We then want to have a control algorithm that says, okay, we want to get to that target temperature. If we're below that, then we know we need to heat. So if it is, say, 60, we need to turn on heat until it reaches 65. If we are above that, say we're at 70 and we want to drive down to 65, so we turn on cool. It's not quite that simple though. So our set point would be that 65, but if you think about and just look at what this is doing right now it's just simulating this temperature. But let's say we're at 60 and we're driving up to 65 as our target temperature. When we hit 65, if we immediately shut off the heat, we might come back below 65. So let's say, at 64.9, it gets to 65, turns off heat, and then you have some sort of, flow of air in the room where the thermostat is, and it drops back down to 64.9. It turns the heat back on, it goes up to 65, and what you end up with is it'll short cycle. It'll sit there and click on and off a bunch of times, and we don't want to do that. It's hard on the equipment. It also is it's an inefficient way to run things. You have the same problem when you're coming down, right? If you're coming down from 70 down to 65, as soon as it hits 65, it shuts off, then it turns back on. It's even worse for that kind of equipment because it's usually spinning up a compressor, and compressors don't like to be short cycled. So we need to avoid that type of behavior. The way to avoid that is with what is called a deadband. So we either go to our target, so we go to the set point, and then we have a deadband around that. So let's say we're heating, and again, we're going from 60 to 65. One way to do it is to drive up to 65 so that we shut off heat, but then we have a deadband of, let's say, 1 degree, and it will cool back down and not turn on again to 60 until 64. And if you were, say, cooling, you would come down from 70, it'd hit 65, and then it would wait till it warmed up to 66 to drive back down. There's another way to do it. You can overdrive it, right? So let's say we're, again, coming up. We go from 60, we pass our set point of 65 through a dead band of 1 to 66, and then we let it cool back off. So really, it depends on whether you want that target temperature to be always maintained, or you want that target temperature to be the edge threshold, right? Now, of course, if we're looking at both heat and cool, we're going to have a dead band. If we set it for 1, we'll have a 2 degree, so 1 above and 1 below. It is typically better to have it set at 65, drive it past that, so it'll go to 65.8, and they're still looking at it going, okay, I understand why it's still fine. And when it hits 66, it shuts off and cools back down. If you overshoot your set point with the dead band, you'll tend to get better response from a user. All of that said, that's what we're going to work on today. We're going to work on putting that together. Now, if you take a look at what we have going on here, we've got this simulated temperature, which is not going to be very useful for us. We really want to be able to control that temperature. If we used hardware like this, and I've got a temperature sensor here, trying to test out when we're above and below for heating and cooling with a physical temperature sensor is a real pain. I'd have to physically warm this up and cool it down and try to get the control algorithm to work. That's ungainly and it's a little bit of a pain. It's also slow. So what we're going to do is we're going to use this desktop application here, but we're going to add in some ability for us to just set this temperature and adjust it. So we'll add a couple of keyboard keys that allow us to change the simulated room temperature in order to drive that control algorithm. So today we're going to have 2 goals. We need to be able to drive this temperature rather than having it do this random walk that it's currently doing. We want to be able to use the keyboard to set that. And then we're going to create our control algorithm, the very basic one that has a set point and a dead band. And it will be looking at both of those to turn on and off our outputs. We already have our outputs driving relays on the physical one and some simulated relays over here on this desktop. We might put a little icon up in the corner that says we're heating or cooling to let us know what the state is. It'll help us to debug that. So let's go get started on this. And in fact, I guess let's start at the end and work our way back. So I'm going to put a label up here that will tell the state that we are currently in. And then we will work on the temperature adjustment, and then we'll build the control algorithm. So first, let's get over into the display service, and I guess we can start with this. We already have a control state here, right? So we have that defined, and that tells us whether we're idle, heating, or cooling. So we're just going to implement this control state in the display service, and it should be here somewhere. It currently throws a not implemented, so we're going to put in a label up at the top. We've got a couple of screens here in this. We've got a splash screen that comes up when you turn it on, and we have the data screen, which is the primary home screen. I'm going to change that to just a home screen because we're going to have multiple screens on this. So now we can just build our control here. I'm going to make it just a 30 by 30 box. We'll put it up in the upper right corner. And so it's got a padding of 5. So we're going to put this state label up there, and we'll set its initial text to a dash. And then I'll come down here and we'll update the control state. So real simple. We're just going to set it to an H if it's heating, C if it's cooling, or a dash if it's any other state. The only other state available is idle. So now let's just update the run to make sure that that is working. So we've got this run that is just an infinite loop. that ticks once a second. So what I'm going to do is just have it cycle through the states just to make sure all of that is updating. Okay, let's run that. And it is not updating, and it's probably because I didn't add it to the display. We can see that we are changing here. So let's come back over to the display service. And yep, right here, we didn't add the state label to the layout. Stop and restart. There we go. So once a second, we're changing our state here. So we now know that if we call update control state on the display service, it changes this. So we've got our feedback loop. Now let's create the ability to change this to whatever we want in code. In fact, let's 1 degree resolution on the display is not going to work for us. So let's go to 1 decimal place so that we can actually see it adjust a little bit better. Perfect. All right, so now we're going to add keyboard keys that allow us to adjust this number here. So we'll have the desktop hardware expose this keyboard publicly. And then I can come back to our main app. Yeah, in fact, we're creating the sensor service here. So let's do this. We're going to pass the hardware into the sensor service. And so now here in the sensor service, we will have access to the keyboard. If we go back and look at the desktop hardware, we have the keyboard already being used, right? And that's for these 2 push buttons. We're probably not going to use those much more, but we'll leave them in. So the H and the C are being used, but let's use the up and the down arrows in order to adjust our temperature. So we can do the same exact thing we did here, right? So we created a push button. And so let's do this, right? We're going to do temp up button. And we'll create a push button with the up. And this has to be from the hardware keyboard. And let's do this. We're going to put in Boolean. This will allow us to change whether or not we're using the keyboard or we're using the simulation, the random walk of the temperature. So if we simulate temperature changes, we'll let this happen. Otherwise, we're going to wire up the up and the down buttons. Seems like a good starting spot. So that'll give us our current temperature. And then on and up, we're going to do current Fahrenheit plus 0.01. So we'll go up, nope, 1/10 of a degree. Again in Fahrenheit. And then we'll set the current temperature sensor to the new temp. So when the up button is clicked, we're going to get the current temperature, or 65. If it's null, we're going to add 1/10 of a degree to that temperature and then reset it. And on down, we will do the same thing, except we'll subtract 1/10 of a degree. So that should do it. So now let's just save and run this. Helps if I change the key here. All right, so the temperature is not changing here, and my bet is that is because we don't do a priming read. We're waiting for a temperature change. So that is a logic change that should happen in the app here. But if I push up, it goes up. Up again. and then down, right? So now I can use my keyboard to control the room temperature. This is going to be critical for us being able to develop the algorithm that turns on and off heat. So we have the ability to adjust the temperature here, and we have the ability to output what the current state is. So now really all we have to do is we have to create that algorithm that ties this temperature to our control state. And for now, we're just going to hard code both the set point and the deadband because we don't have any way to adjust them right now. We can go in and change the code a couple of times to make sure that it's not tied to, a hard-coded value, but as long as we're using variables, that shouldn't be a problem. And then at some point, we're going to have to build a screen that allows us to let the users change what the set point is, maybe change what the deadband is. Typically, you wouldn't have that. That'll just be some sort of a configuration file, but we definitely have to allow them to change what that set point is because it may change via a schedule, right? So in the mornings, you want it to warm up, and at night, maybe go cooler or inverse in the summer, that kind of thing. So let's go start working on that. That control algorithm is going to be here in our main controller. So let's just start by creating two variables that we know we need. Okay, so now the control algorithm is really, really going to be simple in this, which is really nice for us. We know that we want to be able to read the current temperature from our sensor service. If the current temperature is less than our set point, we want to turn on heat. If our current temp is greater than our set point, we want to turn on cooling. Now, this is a good example of that deadband, right? This would immediately drive up past the set point, then turn on cool to drive below, and then turn on heat to drive above. And it would sit there and cycle between air conditioning and heat, which is definitely not what we want to do. But that does get us at least changing that. So we need that idle when it is in the deadband. First, we have to take a look at what the current state is. We're going to have to keep that here. So let's do a public control state. So we're going to set it as a field. And then when we set the control state, it will update the field, but it will also update the display. So now let's take a look at the current control state. So if we don't have a temperature yet for the sensor service, we're just going to loop and do nothing. Then we're going to take a look at our control state. If we're idle, that's the easiest. We know we either need to turn on or off if we are below or above our set point. So if we are heating and the temperature gets above our set point plus our deadband, then we want to turn the heat back off. And similarly, for cooling, if our current temperature is less than or equal to our set point minus our deadband, then we want to set cool state to false. So now let's initialize these to some values. I think we have it starting up at 68. Or was it? Yeah. So we're starting with initially 68. So let's just set it to 70 to begin with. And our deadband equals 1 degree. So let's go through this control algorithm one more time to make sure that we logically understand it, and then let's test it. So our set point is 70 and our deadband is 1. So if we're starting out at 68 for our current temperature, and we're in idle. So we know that the current temp is going to be below the set point, so it's going to turn on the heat. Setting the heat to true again when it's already true will have no effect. The relay's already closed, so it's going to stay closed. So what's going to happen is heat is going to start to rise. It's going to get to, let's say, our set point of 70, and we're going to be in this heating state. So when the current temp is 70, it's still going to continue heating because this has not occurred. And then when it gets beyond the set point plus deadband, so it's 71, it should turn heat back off. Then the room temperature should start cooling. It'll get down to, say, below 71, but it's still above 70, let's say 70.5. At that point, we're going to be idle. 70.5, we're not below the set point, but we are above the set point. So then it would actually turn on cool. So we know that is not what we want it to do. So we need to fix that. There's probably a hole in my logic, or at least my thinking, but for right now, what I'm going to do is I'm going to add the concept of how, the thermostat's going to know kind of what mode it's in based on season, right? It's very rare that I could think of where you're going to be able to need both heating and cooling in the same day, or at least within the same couple of hours. Maybe in some climates, you might need to heat at night and then cool during the day. But what I'm going to say is, if we've been heating within the last 2 hours, I'm going to just rough guess that. If we've run heat in the last 2 hours, then we don't want to run cool. Or if we've run cooling in the last 2 hours, then we don't want to run heat. So I'm going to set that as a 2-hour changeover. So now, let's go back to the sticking point that we were at. So we're heating up. So we're coming from 68. We hit 71. So we hit 70 and it turns on the heat. Then we hit 71 and it turns the heat back off. But now we're at 71, so we're in idle, and our current temp is above the set point. So it's going to want to turn on cool. So what we want to do is only adjust it if heat has not been on in the last hour. We're going to record these. And I'm going to record these when we shut off. So when we turn the heat off. All right, so the cool state, we're only going to turn it on if the last heat time is more than our changeover time, which is 2 hours ago. All right, so let's logically go through this again. So we're at 65, we're idle. We've not heated or cooled at all. So we're going to come in, we're idle. The current temp is lower than the set point. Last cool time is null, so we're going to turn on heat. It's going to heat up. We're going to get to our set point. It's going to not do anything. We're going to get to our set point plus our deadband, so 71. We're going to turn the heat off, and we're going to set this last heat time. So we're at 71. We're going to come back up and it's going to go, oh, current temp is above our set point. True. But it's going to say, is the last heat time not null? Correct. Is the last heat time before now plus 2 or now minus 2 hours? So more than 2 hours ago? It is not, so it's going to not turn cooling on. So it'll only turn it on if the heat hasn't been on for the last 2 hours. If that makes logical sense. All right, let's just give this a try. Okay, so it's sitting here idle. Again, we don't have a temperature recorded here because this display is only event driven. It is not priming that with a read. But let's push the up arrow. So we're at 68.1. We know that our set point is 70 and our deadband is 1. So if we increase the temperature, it's heating up. In fact, let's walk through this control state one step. So let's just put a breakpoint here. Our current temp is 69 degrees Fahrenheit. 69 point, whatever it was, 2, 69.2. We are idle. We know our current temp is below our set point. Our heat should be on. So if it's null, I think that's what it's supposed to be. All right, so let's put a breakpoint in here and start it up again. We read our current temperature. Current temperature is 68. That is less than our set point. We have no last cool time, so it's going to set the heat to true. And in fact, if I bring up this, we've closed the heat relay, which should turn on heat. And then we're going to set the control state to heating. And in fact, what I could do is I could change this to actually drive that output service when we set the control state rather than having it just update the display service. That might be a better way to do this, in fact. To keep all that logic in one spot. But so our control state goes to heating. I'm going to remove this breakpoint and run it. And you can see we're at heating. Now I'm going to drive the temperature of the room up using the arrow keys that we've plumbed through. And so our set point is 70, right? And I think we did a greater than, or did we do greater than or equal? Okay, so we did greater than or equal. So I'm going to put a breakpoint here. So our temperature is not, I mean, it is currently 69, almost 70, but it is not going to be greater than 70 plus our deadband. So I'm going to put a breakpoint in here. It should only stop in that. So even at 70, we're still heating. Now it should heat through our deadband. So we're at 71. Now it has not changed, but my bet is that this is just due to decimal rounding. So yeah, so we're at 70.999, so not quite 71. And this is 70 plus 1. So if I go up one more, that puts us above, and that's going to turn the heat off. So go back to idle. And then it's going to record our last heat time. And I'm going to put a breakpoint back up here in the control state. So we can see that it's not going to turn cool back on, right? It shouldn't turn the cool on just because we're above. So let's walk through this. We're now idle. Our current temperature is now above our set point, but the last heat time is no longer null, and it is less than 2 hours ago, so it's not going to turn cooling on, which is the behavior that we want. And so it goes back to idle. Now we're going to cool the space back down. Here's 70, and it turns heat back on, heat back up. We can remove that breakpoint, and it goes back to idle. So then we're cool back off down to 70. Heat turns back on, drives us up to 71. Turns off. So we're sitting in this 1 degree dead band, heating, and then goes back to idle and cools back off. Now let's do a cooling cycle. So we'll restart the app. And the reason I have to restart is because it's recorded that last cooling time. In fact, let's stop it because it's going to immediately go to heat. So let's set it. We're starting up at 68, but let's set this down to, say, 66 with a 1 degree deadband. So now it should want to cool. So let's debug this. You can see the cool relay closed. It is in cooling. And I'm going to drive the temperature down. I think 66 was our set point. So it should go 1 more degree. And it goes to idle. Cooling relay opens. And then, since we're idle, we're no longer driving cool. We assume that we're going to heat back up. And then it cools again. So it is now driving us in this dead band. So it is doing all of these things that we expect it to do. It's driving the relay. It's changing this mode here. The one thing I want to do is we're going to change where this happens. So the current control state, I'm going to make this private so it can only be driven inside here. Switch the current control state. And I'm just going to move these here. Now I can remove the output service calls down here because we are just setting those. So that's it for this week. We've made some good progress. We've added some features. We are driving toward getting this thermostat working so that we can actually build some hardware and install it and actually drive heat and cooling. That's all I got for you for this week. We're making some good progress. We'll see you again next week. Thanks for watching.